So I'm going to talk about CRDTs, but I'm also calling this talk, what's next for version control? So think back, maybe you've been burning for a while. What was the one time where you wasted some time, or you lost some work, but was just messed up with what you do? Like maybe you ran the test and it failed, and you had a bunch of logging and none of the logging showing up, and then you realize, oh, I forgot to save them. Or maybe you get to the end of the day and you commit everything, you push it up, you go home, you relax, makes it done, and you get a Slack ping that says, hey, the branch doesn't work. Did you forget to add a file to the commit? Think back to when the last time I was that kind of thing happened to you. Was it annoying, frustrating? Maybe a little embarrassing to compare it to pushed up with someone who you're trying to impress. Let me tell you about a time when I had my first job, like 15 years ago now. This was a JavaScript job, and I was new, and they wanted to give me like a self-contained project for weeks, and then thought, great, you can build the date picker. And you've probably seen date pickers on websites, see like face rectangles, but they click the buttons, and they pick equal to one button of the days that everyone hates because they're so slow and annoying to use. But luckily, our user base was pretty keyboard first. We were people who want to keep that hands on their keys, so we decided like we're not going to build this sticky cookie monster boom. Instead, we'll give you a text box. So let's type whatever you want. And this was a really fun project because you have to like figure out from what someone's typed. So like, what did they do? And I think it's like 3rd of June. Well, I didn't say 3rd of June, but only 3 days, like Sunday. Or if they type 3M, is that going to be the 3rd of May or in 3 months or 3 minutes? There's like no real way of knowing. You have to build up a whole bunch of rules and heuristics to figure out, well, 3M is probably 3 months, but 30M is probably 2 months. So I spent like 2 weeks working on this. It was super cool. It worked amazingly. And we got to the end of Friday, and one of the things this company did was demos. And so I demoed it to the team, and they're so excited. They're like, this is amazing. Like, you just type in anything you want, and it knows what you're doing. I even added support for Fortnite, so that's what we pay. And so everyone's happy with it. I'm very proud of what I built. And my boss says, great, can you just search that up? I want to take a look at the code. Even more fun. The demos are over. I go back to my laptop, I sit down, and I don't know exactly what I typed, but it was something like git fetch, git checkout main, git commit that shit. It didn't work. And I did git commit -a, and instead of Vim popping up for the message, it just said, no changes to commit. Welcome to open. What happened? And so I started Googling frantically, like, why haven't my changes? What went wrong? What did I do? And it pointed me to the ref log. It's like, no worries, you just go back in time, look at the ref log, find the things, and I look in the ref log, and I've done nothing in the last 2 weeks. I didn't know yet. You have to commit all the time. So I keep Googling. I find this amazing pull script on Stack Overflow that will go into your Vim history file, and it will like take all the undo logs, and it will like play them in reverse and build up the file for you. Yes, I got it. So I download the script and I run it, and it gives me back the last 100 changes. Oh, that is not million. Fantastic, right? Oh, I go to the company chat and I type in like, sorry, messed up something with it. Like, I can't finish this tonight, but I'll get it to you by Monday. And at that point, I realized that I probably wasn't going to go hiking tomorrow. I was planning to go hiking with friends and like explore the Bay Area with that. Instead, I was going to be sitting in the desk in my bedroom and just typing out 2 weeks' work. And that was 15 years ago. And we use better tools now, right? We're not just use Git, right? Right? The funny thing about this is like, with the software engineers, like we fix things. And if you look at how document editing has changed, everyone uses Google Docs and Notion or Office 365. They go into the document, they type their thing, and as they type, all of the changes are sent to the server and they're backed up. And that has a secondary advantage of like all the changes go to anyone who's interested in collaborating on the document so they can work on it together. And you can't mess up, you can't lose work, you can't waste time doing this because it just works. And then we saw the same problem with design. You don't want people in Illustrator, which crashes all the time. We'll put them in Figma or Canva, and you just do stuff. And as you build your rectangle with big circles, it just sends it to the server. Can't lose your work, can't lose your cloud. And if someone wants to come in and change the border radius as you're working, then you can just do it. It happens in real time. You can collaborate and solve things together. And in all this 15 years of fixing this problem for everyone else, no one has been looked down in the software engineering box and said, oh, maybe we should fix this. So I work at Zed. We are known to build an IDE at text editor. If you haven't tried it yet, I would encourage you to try it. We hit 1.0 2 months ago, which is kind of on our line of the sand. Like, well, there might still be bugs, but for most people, it works very, very well. But if you look at the website of Zag and you look at the mission statement, it doesn't say build a text editor. The mission of Zag is to fundamentally improve how software is built and collaborated upon. To fundamentally improve how software is built and collaborated upon. So, we did this. We built the text editor that we want to use. And now we're going to solve this problem. This problem where it's so easy to lose work as software. So this is kind of a new thing. We have an alpha. I'll share a link later. We've got it out. We spoke about it more. But we're trying to build a thing called the DeltaDB. And the idea is that DeltaDB will do that the collaboration layer for software. It's designed so that as you work, the changes stick to the server so you don't lose work. And it's designed, unlike Git or Raw or Irwin or JK, all of these things are based on snapshots. And snapshots are really cool if you want to do deployments. So you can say, cool, this is the hash of all the stuff in this directory. This is the tag that I hash. And it's a really nice blog you can move around. But if you're trying to collaborate, you can't be sending this giant blog around all the time. You want to go in, and as you're changing things and you're making these tiny changes or deltas, it's like, oh, you want to sync those around instead. Or set up the DeltaDB. So this is a programming meetup. I wanted to dive in a little bit to how some of it works, talk actually about CRDTs, and that kind of come back to Nate here as well. I'll jump over here. So did you retype everything? I did. I'm never convinced that the second version was as good as the first version. It's hard to tell. What could it be? It could have been. It could have been. And also, I had this vision because I was naive at the time. I was like, cool, once I built this, every website in the world will use it because it'll be better than the pointy clicky thing. No one else. Okay. Oh. One day. CRDTs, conflict-free replicated data types. The F is silent. The goal of a CRDT is to solve a synchronization problem. So if you're building a text editor on one laptop, as the keystrokes come in from the keyboard, they arrive one at a time in order. It's kind of obvious what's going on. If you're building something like a Google Docs where you have a central server, the keystrokes still arrive in order, even though they're coming from many machines, because this server has it can define what happens before what. But with software engineers, we like to do things distributedly. We don't have to rely on the central server. And so we're going to use the CRDT to solve the problem. What is the problem? Let's dive into a very simple example. Let's say you want to work on a text document together. You need some way of saying what changed in this text document over time. An edit delta. A naive way of doing this is broken, we'll talk about why, would be to say, I'm going to insert this string at this position in the document. The replace is a range so that deletes can be modeled as like you take a big range and you replace by now. So how would this work in practice? Let's say that you and I start with this imaginary string activity at the top. I'm over here on my computer and I'm going to insert C at position 0, and then I'm going to send you one of those edit buffers over the wire. It says insert C at position 0. You're over here on your laptop and simultaneously you've typed REA on your computer and you send me that message to insert REA at position 0. After you send me that message, the message I sent you arrives. And you go, great, I'm going to insert C at the beginning of the document. And so you end up with C, creativity or creativity. Sounds about right.
All right. A little louder.
Louder? I'll try. But on the other side, if we do things in the other order, so on this side, we've inserted the C that already exists. We have this C-tivity, and then I get your instruction that comes over the wire, and it says insert REA at position 0. And I do that, and I get reactivity, which is also plausible, but we have a problem. We think we agree on what's going on, but we've ended up in two different states. So this is the problem that CRDTs solve. There's a lot of research that's gone into them. And the classic way of solving this is to say, well, usize doesn't work. You can't refer to a position in the document by its index because it's not stable. Instead, what we're going to do is we're going to give an ID to every character in addition to the character itself. And these IDs are designed such that they're unique across the whole system. And the way that is typically done is you have an actor ID, my laptop will have an actor ID, your laptop has an actor ID, and then we have this sequence number that we just keep incrementing. How does this fix the problem? Don't be too afraid. I think it makes sense. So we start with the same document we had before, this activity, and these characters have IDs C1 through C6. I'm on my machine, I insert character B7, B because my actor ID is B, 7 because it's one higher than 6, and I insert that before character C1, it's a C, and I send you that instruction, insert character B7 before C1. Over on your machine, simultaneously, you've inserted REA, A7 through 9, because you're at A, just before C1. And after you've done that and you sent me that instruction, you receive my instruction. And it says insert C just before character C1. So you go and you look at your string and you say, well, that's interesting. Just before C1, I see A7, A8, A9. And you're sending me a character B7. So when you generated that character B7, you didn't know about this stuff yet. Otherwise, you wouldn't have chosen those IDs. So we can observe that there's a conflict. What are we going to do about it? We need some way of resolving that conflict that everyone agrees on. Typically, this is done by sorting the actor ID. So A sorts before B. That means that we are going to leave the A7, A9 where it is, then set the C, and then the rest of the variants. And so that leaves this side with the string reactivity. If I go back to my laptop, yeah.
Does that mean like the lower ID will always thing?
Typically the lower actor ID, because you just need some way of resolving these types of dynamics. Over on the other side, the opposite thing happens. I've inserted the C already. And when I get your instruction to insert for character C1, I see B7, I see you're giving A7, this conflict. We know A goes before B, so I'm going to insert your change before mine, and we're going to end up in the same document state. We both end up with reactivity across more.
So even if it's wrong, we both agree.
Exactly. And there's a really fun talk by Martin Clapham on how to implement CRDTs wrong, basically. Because it turns out the choices you make about how to resolve it give you very different properties. So this is the standard solution, and it works, and it's fine, but there are two problems. One of which, if you go back and look at these things, you'll notice that each character, which is typically 1 byte, programs are mostly ASCII, has a character ID which is typically 24 bytes, because the UUID is 20 bytes and the new size is 4 bytes. And that's a lot of bytes. Luckily, research has been done, like you can compress this really well. It's a very compressible structure, but there's a lot of data to manage. The other problem gets to what I was saying about snapshots. So if we want to build a collaboration layer for software, it needs to integrate with the version control system you already use, which is probably Git, although maybe that's changing soon. We need a way of talking about positions in Git commits. And we tried this, we can go through your entire Git history and add an ID to every character in your entire Git history and build up the entire history again. But it's really slow to do that. So we wanted to find a different approach. And this is what we came up with. So we go back to representing the added delta. It's just an insert as a string, just to replace, which is a range of new size. But we give you one extra piece of information, which is what was the state of the document at which that new size was valid. And the cool thing about that is that the version can then be either a Git version, because if you have a file with a given SHA, it's exactly going to be the same as I had, modulo SHA collisions. Or it can be a version built on top of each service. So how does that work? This is the last time I'm going to go through this example. So we start with a string. It says activity at the top, and it's the version from Git AO. I'm going to insert my C at the beginning, and I'm going to send you the instruction, insert C at position 0 of Git AAA. Over here, you've inserted the REA at the beginning, and you send me that instruction to say position 0 of Git AAA. But as part of inserting this text into your version of the document, the version has moved forward. It has a delta ID as the top, 8.3, instead of the Git out. So when my instruction comes in and it says insert the C at position 0 of Git AAA, you know, wait a minute, stuff's happening. How do we resolve it? I've glossed over the details a bit here. It says lookup and fragment index, but what we do is essentially the same as the previous slide. Each participant locally has their own idea of the ID of a character, which is local and it's not safe. So we can go back to version Git AOL. We can load up the CIDT at that point. We find position 0 and we go, okay, that was character ID X. We then load up the fragment index for the next version of the string, and we say, where is character ID X? And it's going to say, well, it's right here at the beginning of activity. We do the same conflict resolution thing that we've seen before, and we insert things in the right order, so we end up with the output. And the same thing happens on the other side. Yes.
So effectively, it's choosing one arbitrarily.
So it's choosing one consistently. And one of the advantages of not sharing the character IDs over the changes and the deltas is that you can actually keep your own deltas private. So if you look at this, you might have built that git commit up in DeltaDB, building up all of the changes, and then you do a git commit. And you might not want me to see all of the details that went into that. And so you can kind of like end the collaboration here. But when you look it up in your fragment index, you can see all the extra detail that I don't have. But it's essentially doing this exact thing, but we're just asking the fragment IDs instead of the shared character. Okay, that's all I wanted to talk about in terms of CIDs. So if we have this ability to be able to make small changes to the code and send them to the server and send them to the collaborators, that gives us two huge advantages. One is you never lose work because of background. The other is you can actually start to collaborate. So the way that software engineers typically collaborate is you do a whole bunch of work, you send a pull request, and you wait for a review. And then you get a review, and you wait, and you do the changes, and you have this very slow async back and forth. And that's okay for some things. It's good for compliance review. It's good for kind of like two independent problem solvers. But if you want to work on something challenging or interesting, it's actually really cool to be able to work on it with another human. And I think as people are using agents more and more and like pairing with a computer slot, you should try pairing with humans. They're even better than language models of this stuff. And now you have the tools to do that. It's not like you have to screen share and like follow someone else's pass around. You have exactly the same code on both of your machines. You can run the tests. You can explore it with any of the tools with options. So that's the idea behind DeltaDB. There's an early alpha of a QR code you can just scan if you're interested in being part of it, or you can come and talk to me. But just to round it off, I want you to think back to the beginning of the talk and think about the time where you lost time, where you lost work because your tooling let you down. And keep hold of it in your mind, because if we get this right, that will be the last time that ever happens to you.
So is it running like a daemon? Basically, it's watching all the edits of the file, or is it through the IDE that's actually tracking the actual
Through the IDE,
Okay.
we also sync with files.
software? It's like an LSP kind of embedded that you could make. It does it. It's like is it you can do it the LSP directly, or
It's not, we own the IDE, right? And we don't need to do that language or stuff for you. It's like all in that.
And I use the data side with it for my project, for example.
Asterisk, yes, I hope, not yet, maybe. So right now we've actually been building it in like a demo product, just so that we have like it working before trying to rebuild an entire IDE on top of it. My hope is that as part of moving it into Z proper, it becomes an open source library that it could link into other things.
just repeat the questions as they're asked. So
Yes.
I think it's speaking, Oh, it is. Let me get notice. Excellent.
All right.
Thank you.
The marketing, did you do both things for people who don't like AI collaborators? Helps you work with people, but for people who are using AI,
Right.
say this lets you edit while the AI is doing its work, which right now you're
Yes.
frozen and waiting.
Yeah, exactly. And it's like, that's a real problem, right? I don't know if anyone's tried this with an agent, but if you make a change to a file that the agent is looking at, it gets super mad at you. But we can now give you your own isolated copy, and its own isolated copy, and then merge it at the end. And then, yeah, that's a really nice feature of it.
Is there a plan to be able to mark any files or lines as sensitive, prevent leaking secrets to the collaborative DB?
Is there a plan to like mark bits as secret? Yes. And that's one of the advantages of like those hidden deltas I talked about. The way we do it right now is we don't sync zip files. We can't yet like isolate lines in a given file, but that's kind of gets all too. So, okay.
Can you describe how it like integrate with Zed? I mean, will it be in a separate panel or?
So yeah, can I describe how it integrates with Zed? Yes. If you use Zed today, there's a panel on the bottom right with a little space icon. And that's the very, very early prototype of this. So secretly, Zed has been working towards this for a very long time, and they shipped a really early version. We don't want too many people to use it though, because it relies on a single respirator running on a single storage somewhere. So the new version is a lot better, but it works kind of in the same way, where you have a panel, you join someone else's project, and it's just like your own project, except it's in a directory we manage on your behalf.
So this is separate from the collab panel?
It will replace the collab.
Oh,
Okay. If that will scale mountains. So no limits. Yeah, exactly. It'll be okay. Yes.
Then it's crawling it to visualize this somehow.
Yes, we will be able to do that with Cole, who is one of my colleagues, is working on that right now. One of the really interesting things about CRDTs is, as I think someone pointed out earlier, if you just merge things naively, you get a big mess. And so one of the things that we need to do, and we've spent a bit of time on, is actually if there's conflicts in the independent things, although the CRDT can resolve it, we try and resolve it in the way that Git would, so that if there's really close together edits, we give you a merge conflict marker, so and so it will feel a lot like Git diffs, but we can do it character-based instead of line-based.
Talk a little bit more about the Git integration, or how it breaks, where you lock down and get opening.
Yeah, can I talk more about the Git integration works? It turns out it's complicated. So it has all these things. We want to be able to build off the Git versions, because realistically, we don't think we have a chance of getting people to stop using Git yet. And so you build a Delta branch kind of off the top of the Git commit, and there's no real notion in the core of the Git branch. However, obviously, when you're working, you want to know what branch you're on, and you want to do those things. And so we have extra metadata to pull in the branch name. The original plan was to use Git work trees to add a new work tree to the Git repository. Work trees are terrible for a lot of reasons, but part of the reason is you might have more than one issue working on the same branch, and then it's how do that? Not made us sad. There's another feature of Git you can use where if you give it a shallow repository clone, and so the data is all shared through magic I don't understand, but you can actually have multiple copies of the reps checked out. So that's what we're doing right now. There are some problems with that, so we'll see it. But
You look at dark sort the dual or managing Gits, or is it going to be CRDTs on top of it regularly?
But now we looked at Dark Sun's dual. I have as just getting my bearings in the space. I like that they are patch based, not snapshot based, but they're still not Delta based, right? And it's trying to get down to that super fine grained thing. So as inspiration, I'm the idea of oh, we could change things, yes, but in terms of implementation, it's very different.
I'm just wondering practically how many people can work on a simultaneously, 20 you overdoing it.
Well, so you're wondering how many people can work collaboratively. We tried on Monday. We have a team meeting every Monday, and we tried to have everyone in the whole company use the thing. And for about half the people it worked, and the other half it panicked for unknown reasons. So yeah, 10 I think is a reasonable number.
Okay.
And because the unit of concurrency is a Git branch, it's not a whole repository apparently. I think that's going to be what's going to look bad.
Isn't that for the old super Dura?
I'm not familiar with Dura.
It was a server you started in your Git break file. You started there, and it would actually just watch, and every time you hit save, you'd identify, it would write a diff from a given timestamp. And so if you got control or an agent is something screwy, you could halt it. You could pull up a graph showing every diff since you started Dura. You could roll back in time.
Nice.
For something like even AKT, where I I can fix that, and suddenly my PR is unreadable. Being able to roll back to the point where I lost control of my development process was glorious.
Yeah.
Except it was a really crappy UI and experience using it. How does this differ from that sort of thing in terms of designing it?
So I guess the problem we're trying to solve is very similar, which is as changes are made, we don't want to lose them. But for us, it's not you don't even have to remember to save. I think in an early version of this talk, I was comparing this Figma where you save changes durably to multiple machines at the same time. But the way that most programmers we manually manipulate volatile RAM, and we don't even save it to this until it's good. It's like, I don't know, it's dangerous. So that's the idea. One of the design concepts we haven't built yet, but I want is kind of the history scrubber or like the under tree from Vim. So you can just kind of like swipe back through time to see kind of where you're at. But I don't know. That's the nice thing about being an early product. We haven't opened all that.
So if I'm understanding this right, if I was monkeying about in a function and you decided to move that function somewhere else, it would actually solve that properly instead of just make a big old mess of it.
Yeah. So I guess the question boils down to like, can you handle move edit conflicts? Right now we don't. And we don't because Git doesn't, and you end up in this awkward thing of like, is that a safe change to leave? There are CRDTs that do solve that problem. Some were training one last night where you can like move chunks of the file around, or even have a visual style where you move chunks from one file to another file and it retains the identity. We haven't built that. We could add it, but it's dangerous to build this difference, if that makes sense.
Oh, when I want my IDE's cursor to jump where something they move
Right.
it, right?
As you're dragging it around because of work. Gotta do it.
I have a question from Zoom. Will the underlying CRDT library be open source?
Will the underlying CRDT library be open source? Yeah, the hope is yes. We want to get it to a point where we're comfortable with it and like it's working well. I think if we were to open source it right now, everyone would find all the bugs that we would like to do that. So yeah, as part of like getting this into set and getting it like broadly available, it will be open source, but I can't tell you why.
What will the impact of like packet browser or latency on the operation of the database?
What's the impact of packet loss or latency? The idea behind CRDTs is it doesn't matter, and that's kind of the problem they solve. Is like the latency of a packet could be arbitrary, and you can still merge the puppets. And so the underlying structures are built with that in mind. On the flip side, kind of as we were talking about, if two people are making changes to a code base and then you just like jam all those edits together, you don't end up with valid code. And so I think we have it's like 3 minutes right now where we stop doing the CRDT thing and we say, actually, no, we need to be more in sync with that. But yeah, in theory it works, in practice it's product code.
Have you considered making all of them also get comments? As in my editor, every text edit also becomes a git comment in another namespace.
That's cool. Have we considered making them all git commits? No, but why not? I guess. We have one more. I can't tell.
Things here doesn't DB like a full database, or if it was like on like leverage on something that has data durability already.
Is it a database or is it a clever schema? It's a clever schema. Currently, the backend is SQLite. And for the really Rust nerds among you, I was talking about all these like fragment indexes and B trees. The way we implemented that for Vector works is we have a version of Arc that is a SQLite backed Arc. So you can clone a node in RAM and it increments the ref count of the database system. And that allows us to like load immediately and only read the bits off disk we want to. So yeah, SQLite is like the powerful engine, and then DeltaDB is this layer of sending the changes around. Cool. All right.
Thanks, Conrad, for that.